Notes and reminders on how to add and subtract signed numbers, and we'll also look at properties of real numbers, such as commutative, associative, distributive properties that you may have forgotten. So always a refresher. Okay, let's take a look at adding two signed numbers. Example, -16 plus 13. I encourage you, when you do this, I encourage you to think about money at first, before you do rules. Think about, the bank account. If you're $16 in the hole, okay, if you've got -$16 in your bank account, and somebody gives you 13, you're not totally out of debt yet, right? So when people think about money, they say, okay, yeah, I'd have 3 more that I'd be at -3 still in my account. Now, if you wanted to make a rule, though, in words, a lot of people say, okay, when the signs are different, this is a -16 and this is clearly a +13. Notice this sign belongs to 16 and this sign belongs to the number to the right of it, to 13. So you have different signs. A lot of people say just subtract the numbers. So if you're looking for a rule, unlike signs, different signs, or a recipe, you subtract and the answer takes the sign of the bigger number. Subtract, this pen's being a little fussy, subtract and bigger number wins, meaning the answer takes the sign of the bigger number. Now that's just little gimmicks to help you remember, but if you just think about it intuitively, it'll make sense. If you're 16 in debt and somebody gives you 13, you're not out of debt yet. You'd be at -3. Okay? Let's try another one. Now with this one, we have -2/5 plus -3/20. Well, both of those numbers are negative. So they're like, now if you're thinking about money, 2/5, easier to think in decimals, but if you're in the hole, a little bit of change, meaning you're in debt, a couple cents, and adding on, this translates to adding on more debt. If you're adding a negative, you're adding on another loss. So you're going further in the hole. So a lot of people say, okay, if the signs are like, I'm just going to map this out in words, like signs, we're actually just going to add the two numbers, and the answer takes the sign of that problem, which is negativity. So the answer will be negative. But now here we're obviously dealing with fractions. So let's think about the LCD, 5 and 20, least common denominator is 20. 2/5 is mathematically equivalent to what? Well, how does 5 become 20? Times by 4. So if you times 2 by 4, you got 8. Multiply, 2 times 4, you get 8. So now we know that 2/5 is 8/20. So now we've got -8/20 plus -3/20. We have our common denominators. We can travel straight across. So -8 plus -3, that's -11/20. And again, we knew that answer was going to be negative because we said we're just going to add those two numbers, in their positive form. 8 plus 3 is 11, 11/20, and then just keep the sign of the problem. So that is a good rule to do when you have like signs. Okay, hope that helps. We're going to try one more of those. Okay, so here we have -5/6 plus 4/21. Clearly, this guy's negative, this guy's positive, unlike signs. So if you're just thinking about recipes, unlike signs, you're going to have to subtract and the answer takes the sign of the larger number. But sometimes it's hard to judge what the larger number is when you're dealing with fractions. And no, we're not going to convert them into decimals. We're going to keep wheeling and dealing in fractions. So let's go ahead and get the LCD. I always tell people, if you can't get the least common denominator off the top of your head, just go ahead and multiply these two numbers and get a common denominator. You can always worry about reduction at the end. So that'll kind of save time sometimes. So 21 times 6, all right, that's 126. So we can temporarily use 126 as the least common denominator. So 6 goes into 126, obviously 21 times. 21 times 5 is 105. Okay, we'll keep the negative sign, plus sign. 21 into 126, obviously, to get from 21 to 126, you have to multiply by 6. So 4 times 6 is 24. Now, luckily with fractions, you can kind of think about going straight across. -105 plus 24. Well, the bigger number is the 105. So really, we're going to take 105 we're going to take the difference of those two numbers. So we're going to subtract, and answer takes the sign of the larger number. So now we can see that this number is bigger than this number. So we know the final answer is going to be negative. We just need whatever the difference between 105 and 24 is. Okay, so I'm just going to go off on the side, 105 and 24. Again, thinking without a calculator here. Okay, so 81. So now I have 81 over 126. I know it's going to be negative, but now because I didn't pick the least common denominator, that's where it gets a little sticky. You have to ask yourself if you can reduce this thing. And I love the divisibility tricks, though, because they really tell you what to do. 6 plus 2 plus 1 is 9. Again, that's sum of the digits. And 8 plus 1, if the sum of the digits is divisible by 9, the number is divisible by 9. So 81 divided by 9 is 9. And 126 divided by 9 is 14. So we're arriving at negative 9/14. All right, hope that helps. And last but not least, for this little session here, we're going to take a moment to think about algebraic properties, commutative, associative, and not all of them, just a few. We're going to hone in on commutative, associative, and additive inverse properties. So just 3 for today. Okay, so as I said before, there are many properties of real numbers. We're just going to sort of hone in on the commutative, the associative, and the additive inverse properties. There's the multiplicative inverse, there's the distributive property, there's properties of 0, but I'm going to hold off on those. I don't want to overwhelm you with properties. So these are some very important ones, and that's why I'm focusing on those. Okay, commutative. Some people say, oh, isn't that the one that, order doesn't matter? So A plus B equals B plus A. So the commutative property is true for addition. It's also true for multiplication, and that A times B equals B times A. That we can say it in either order, and it's true. Now, if you need numbers, just think about it. Is 7 times 3 the same thing as 3 times 7? Sure. Okay. So order. Commutative property has to do with order. Okay, and that it only holds true for addition and multiplication and not subtraction and division. Now let's think about associative property. That may not be as believable. Do we believe that A plus B plus C, with these guys in parentheses, is equal to A plus B plus C with these in parentheses? So think about numbers. Is 7 plus 4 plus 5 with those in parentheses the same thing as 7 plus 4 plus 5 with those in parentheses? Well, here 7 plus 4 is 11, and 11 plus 5 is 16. And here 4 plus 5 is 9, and 9 plus 7 is also 16. So 16 equals 16. Aha! It appears to be true for addition. Turns out it's also true for multiplication. So we can say it holds true for multiplication. So A dot B dot C is equal to, so I'm just starring that, so it's also true. So A dot B dot C, a lot of people say, okay, so this is the property where you switch the parentheses. Grouping. It has to do with grouping. And that's very much true. Okay, and then additive inverse. We've known that since we were little. We're just putting a fancy name to it. That says that anything plus its additive inverse, so A plus negative A, the opposite of A, will get you to 0. Now if you need numbers, think about 7 plus negative 7. Well, sure, because if you have 7 in your bank account, and you lose 7, you're at 0. Okay? So that's just anything plus its opposite. It's going to bring you to 0. All right, hope that helps.